This is a quick review for chapter 7, especially the material that we're going to see in the next couple chapters. So we completed this graphic organizer in class already. So if you need this again, all the answers are already filled in on Moodle for you. But this is a great place to have a summary of everything you need to know from chapter 7. So you really want to focus on what you know and what you need to find. So if you have a right triangle where you know two sides and I'm asking you to find the third side, that is when you use Pythagorean theorem. If I give you a right triangle and you know that the legs are congruent, so you see a right triangle and you notice the legs are congruent, that is a 45, 45, 90 triangle. And if I'm asking you to find the other two sides, you're going to need to use your rules. So leg to hypotenuse, multiply by root 2, hypotenuse to leg, divide by root 2. If you know that there is a 30 or 60 degree angle in your right triangle, so you see a right triangle and you notice that there's an angle that's either 60 or 30 given to you, that's when you need to use your 30, 60, 90 rules. And remember, you always need to find the short leg first. And if you know the short leg, that's where you want to start. When you are working with Pythagorean theorem or the special right triangles, which is the 45, 45, 90 and the 30, 60, 90, we need to have exact answers only, meaning no decimals. You should be simplifying your square roots and keeping fractions. Now we use trig as a last resort because when we use trig, we have to have approximate answers. So we will have decimals with trig and there's no way to avoid that. So if you see a right triangle and you know one side and one angle, however, the angle that you know is not 30, 60, or 45. If the angle is 30, 60, or 45, then you need to use those special right triangle rules. So what you're noticing here is you know an angle that's different than 30, 60, or 45, and we have one side. And I'm asking you to find the other two sides. That is when we use SOHCAHTOA. So remember, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Now, in the chapters to come, we won't use inverse SOHCAHTOA quite as much, but it is fair game to show up. So in this case, it's when you know two sides, and I'm asking you to find the angles. Finding angles is when we use inverse SOHCAHTOA. So SOHCAHTOA is treated the same way. It's just you have to press the second button before you press the trig button in the calculator. And make sure for all of this that you are in degree mode in your calculator. So here's a couple examples. Number 1, we know two sides and we want to find the third. So this is when we use Pythagorean theorem. So we have leg squared plus leg squared equals hypotenuse squared. 7 squared is 49 and 10 squared is 100. Subtract 49 from both sides and we get x squared is 51. So that means x is the square root of 51. Now you would want to make sure you check and see if square root of 51 can be simplified, and it can't. So we are done. Now if you need square root practice, I have square root videos on Moodle. That was back in chapter 5. Now example number 2. What you want to notice is that there are two congruent legs in this right triangle, which makes this a 45, 45, 90 triangle. And what we know is the hypotenuse. So we are going from hypotenuse to leg, and in order to do that, we have to divide by root 2. So I am going to take the hypotenuse, which is 5, and I'm going to divide by root 2. Remember, division looks like fractions. Now I can't have the square root in the bottom, so I'm going to multiply top and bottom by root 2. And then in order to multiply here, we multiply across the top, which is going to be 5 root 2. And then we multiply across the bottom. Any square root times itself is just the number underneath. So root 2 times root 2 is 2. I would want to check and see if I can simplify this 5 and 2, but I can't. So that is my answer. So both of these legs are going to be 5 root 2 over 2. So it looks funky, but that's our answer. All right, and example number 3 is another 45, 45, 90 triangle, because what you want to notice is that the two legs are congruent. And in this case, we know one of the legs. So in order to go from leg to hypotenuse, we have to multiply by root 2. So 6 times root 2, the best we can do is just squish it together. That's 6 root 2. So your hypotenuse is 6 root 2. The other leg is 6 because we know the legs are congruent. Okay, in example number 4, this is a 30, 60, 90 right triangle because you see your angle that's given to you is 30. So as soon as you see that, you want to be thinking of 30, 60, 90 rules. When we're working with a 30, 60, 90, we always want the short leg first. And our short leg is across from the 30-degree angle because that's the smallest angle. So we are given the short leg. Now, this angle, this last acute angle would have to be 60. So across from 60 is your long leg, and always, always across from 90 is your hypotenuse. So we do know what the short leg is here. So that's a great place to be in. So to go from short to long leg, we have to multiply by root 3. So 5 times root 3 is 5 root 3. So our long leg is 5 root 3. Then to go from short leg to hypotenuse, we have to multiply by 2, and 5 times 2 is 10. Now, number 5, look closely. We are given a 60-degree angle. So again, this is a 30, 60, 90 triangle. And remember, we have to find the short leg first. And right now, across from 60, this is our long leg. So the other acute angle would be 30 degrees. So across from that 30 degrees, that's our short leg. That's the one we need to find first. So we know the long leg and we need the short leg. The rule to go from short to long is divide by root 3. So I'm going to take the long leg, which is 10, and divide by root 3. We want to rationalize and multiply top and bottom by root 3. So we multiply across the top, and that becomes 10 root 3. And then we multiply across the bottom. Any square root times itself is just the number, so that's just 3. We want to check to see if we can reduce this 10 over 3, but we can't. So that is our short leg, 10 root 3 over 3. Now we have to use our short leg because we do not have a rule that goes from long leg to hypotenuse. So we have to go short to hypotenuse. And to go from short to hypotenuse, we have to multiply by 2. So we have the short leg, which is 10 root 3 over 3, and we have to multiply by 2. Well, this is the same as 2 over 1. So when we multiply fractions, we multiply across the top. So that is 20 root 3. And then we multiply across the bottom, which is just 3. So your hypotenuse is 20 root 3 over 3. Okay, our last two examples, we look at this right triangle and we notice that we have one angle and one side. And that angle is not 30, 60, or 45, which means we're going to need to use trig. So trig is going to use SOHCAHTOA. And we need to look at the side that we know and the sides that we need. So that angle that's 21, we want to label everything based off of that angle. Well, we know that across from the 90 is always the hypotenuse, so we are given the hypotenuse in this problem. And then this would be our opposite side and our adjacent side. So we know the hypotenuse and we want to find the adjacent. So which trig ratio involves h hypotenuse and a adjacent? That is cosine. So we're going to use cosine of the angle, which is 21, equals adjacent, which we don't know. You can call it an x or whatever you want to, over the hypotenuse, which is 13. The unknown is in the numerator. So right now, our unknown is being divided by 13. The opposite of dividing by 13 is multiplying by 13, but we have to do it to both sides. So now this is what's going to go in your calculator. 13 times cosine of 21, and you should get 12.1. Remember to be in degree mode. Now to find the opposite side, we want to go back and use what we were given originally, which is the hypotenuse. So now we know the hypotenuse and we need to. So opposite over hypotenuse is going to be sine. So we have sine of 21 is the opposite side over the hypotenuse, which is 13. Very similar to finding the adjacent side, we're going to have to multiply both sides by 13. And then you type 13 times sine of 21 in your calculator, and you should get 4.9. Now, number 7 is similar. So when we look at this, the angle that we have is 63, which is not 60, 30, or 45. So we know we're going to have to use trig. So we're going to need SOHCAHTOA. So let's label the triangle based off of the angle we know. We know the hypotenuse is always across from 90. Across from the angle we know is the opposite side, and it looks like we do not know the adjacent side either. So we know the opposite, and we need to find the adjacent. So the trig ratio that has opposite and adjacent is tangent. So we have tangent of 63, and opposite is 41, and adjacent, I'll call it x, is in the denominator. Whenever the denominator has the variable, the denominator and the whole trig function will switch places. So this becomes x equals 41 over tangent of 63. That goes in your calculator, and you should get 20.9. Now, the last side we need to find is the hypotenuse. So go back to what we knew originally, which was the opposite side. So if I know opposite and I want the hypotenuse, that would be sine. So I have sine of 63 equals the opposite, which is 41, over the hypotenuse, which I don't know. I'll just call it h. And now again, our variable is in the denominator, and when that happens, it will completely switch places with the trig ratio. So we have h equals 41 over sine of 63. That goes in your calculator, and you get 46.02. The reason I rounded it to 0.2 is because otherwise it would have rounded to a whole number of 46, and that's very misleading. So when that happens, I would suggest just taking it out more decimal places.